Pleasant day to each and everyone. This is at your service, Chiefmate John Ray Sirom, a Maritime College instructor and assessor from the University of Cebu. So in this video, I will be explaining what is a draft survey and solve for the weight of cargo using a draft survey. So let us explain what is a draft survey. So this survey is used to determine the weight of a bulk cargo such as iron ore, coal, steel scrap, grains, and some specific quantities of liquid cargo loaded onto or discharged from a vessel. But in a tanker ship, we do not do draft surveys, but instead we do the sounding of the tanks. No? So there's no need for a draft survey in a tanker ship, only for a bulk cargo, general cargo, and container ships. So draft surveys are convenient and economical means of ascertaining the quantity of cargo loaded or discharged from a ship by reading the vessel's draft, measuring the ballast water, fuel and diesel oil, and other liquids on board, and calculating the final quantity by using the vessel's approved deadweight scales and tank tables, because these consumables must be deducted to the displacement in order for us to determine the weight of the cargo, because that is the primary function of a draft survey, to determine the weight of the cargo loaded or discharged. Draft surveys require only a measurement of the water displaced by the vessels before and after cargo is transferred, along with a measurement of water density, because it affects the displacement. That is why we need to have a correction with regards to the density. Water displacement is measured through draft marks on the ship and converted to a volume using draft tables. The weight of displaced water is calculated by multiplying its volume, the displacement, by its density. So that is how we correct the density. And later on, I will be showing this one to you. So the difference between the weights of water displaced and before and after the cargo has been transferred will be equal to the weight of the cargo within measurement accuracy limits. So which means that if we have two surveys, the initial and the final survey, if we subtract the initial survey to the final, initial displacement to the final displacement, then we could also attain the value of the weight of the cargo. So let's try to solve this one using draft survey. So we have the distance between forward mark and forward perpendicular. So this is already given. This is 1.3. The distance between aft mark and after perpendicular, we have 11.45. So we could visibly see this one in our ship's general arrangements, and of course in our ship stability booklet we have also this one. So next we have non-cargo weight, we have the fuel oil, we have the diesel oil, we have the fresh water, we have the ballast water, and we have also the light ship displacement of the vessel. Then we have also the given tabulated displacement, no, at quarter mean. So we don't need anymore to look at the stability booklet, since we assume already that we have already the given displacement at QM. So we only need to compute for the quarter mean. Next, we have given density, which is 1.020. Then the TPC, which is also obtained in our ship stability booklet. And we have the LCF, and we have the MTC difference. Then we have the LBP and the LBM. So LBP stands for length between perpendiculars, and LBM stands for length between marks. And we have here the given draft. So upon draft survey, the readings are the following. We have forward, amid, and aft. So at port side, we have 7.85 for forward, 7.96 for the amidship draft, and 7.91 for the aft draft. In the starboard side, we have 7.84 for forward, and for the midship we have 7.65, and for the aft draft we have 8.00 meters. So it means that the ship is not totally upright, and we need to consider that one. So we need to get the mean of the two readings in both port and starboard side, forward, amid, and aft. So we have here 7.845 meters for forward, that is the mean, and 7.805 for amid, again that is mean, and we have the mean for the aft draft, which is 7.955. So we could already calculate the trim of the ship. So aft mean minus forward mean. So in this case, we have a ship trimmed by the stern by 0.11 meters. Okay, next is to obtain the trim correction. So we have here the forward correction. So the formula is trim times distance between forward mark and forward perpendicular divided by the LBM. Okay, so if you will be given a problem that doesn't have a given LBM, so what you need to do is to subtract the value of the distance between forward mark and forward perpendicular, and the distance between aft mark and after perpendicular. So you just subtract this value to the LBP, and you have already your LBM. So after knowing the formula, so let us apply this one. So the forward correction would be 0.11 times 1.3 divided by 204.25, which is the LBM. So the forward correction is 0.0070 meters. Now always remember that you should use 5 digit after the decimal. And we have here the forward after correction. So we have the formula trim times distance between aft and after perpendicular, which is 11.45 divided by LBM. So the same LBM, 204.25. So the answer would be, the after correction would be 0.00617 meters. Okay, so in this picture we have here the perpendiculars. So this line here is the forward perpendicular, and this line here is the after perpendicular, and we have the draft at after mark. Okay, so this is the location of the after mark, and on the forward part we have here the forward draft mark. So that explains the distance, the distance between forward mark and forward perpendicular, and the distance between after mark and the after perpendicular. Nowadays, this was already taken into consideration upon building a ship, that the distance between the two must not that far from each other, or probably it will coincide from each other. So after knowing the forward and after correction, let us have the rule of thumb A, which is if the shape is trimmed by the stern, at all times we should subtract the forward correction to the mean forward draft and add the after correction to the mean forward draft. To the mean aft draft. But if the ship is trimmed by the bow, which not frequently happen, or not happening frequently, we need to add the value of the forward correction. Remember, this is trimmed by the bow, and if we are trimmed by the bow, we should subtract the correction. So in this example that we have, we are trimmed by the stern, so we need to subtract the forward correction and add the aft correction to the mean aft draft. Okay, so these two are already obtained when we have the first step, this one, 7.845 and 7.955. Okay, so after applying that one, so we have already the corrected forward draft and corrected aft draft. So after learning the correction forward and the correction aft, we could already have our corrected trim, which is corrected aft minus corrected forward. So the answer would be 0.11687. Always remember to have at least 5 digits for this one, okay, because we are going to use the value of the corrected trim later on. Now we will have the MDP, which is we have the formula correction aft minus correction forward divided by 2. So the answer for the MDP would be 7.90274. So we are going to use this value later on for the quarter mean. Okay, so we have the formula for the quarter mean, which is 3 times the average of a midship draft, which we have given already in our example, plus MDP. So we have obtained already what is MDP, which is 7.90274. So it will be divided, the answer will be divided into 4. So 3 times 7.805 plus 7.90274 divided by 4. So the quarter mean will be 7.82944. So after learning the quarter mean, take the last 3 digits. So the last 3 digits of the answer, which is 994. So just put the decimal before 944. So that would be 0.944 times the given TPC, or the TPC which we have obtained in our stability booklet. So in this example, we have already the TPC, which is 62.8. But just in case that you will be asked where did you get the TPC, then it is achieved through the reading in the stability booklet. So in our stability booklet, we have the receipt 7.82 and the equivalent TPC. So we have already the increments. So this is 0.944 times 62.8. The increments would be 59.2832 tons. Okay, so we have the increments which will be added to the tabulated displacement at quarter mean. Okay, so we have to get the trim correction. The first correction is the formula is TPC times LCF times trim times 100 divided by LBP. So the other term for LPP is LBP. Okay, so do not be confused with that. So the first correction is 62.8 times 5.56 times 0.11687, which is the trim, times corrected trim, times 100 divided by 217. So the answer for the first correction would be 18.81 tons. That is the first correction. And for the second correction, this would be 50 times MTC difference, which is already given, times trim squared divided by LBP. So again, LBP is equivalent to LPP. That is the same. So we have 50 times 42.70 times 0.11687 squared, so divided by 217. We have already the value of the second correction, which is 0.13 tons. So the rule of thumb, if the LCF is negative, so if the LCF here is negative, then the first correction should be subtracted to the tabulated displacement at quarter mean. Simply because if we have here a negative value, then the answer for the first correction will be negative, and it should be subtracted to the value of the displacement at quarter mean. So we have here the hydrostatic displacement. So the given displacement, so we have already the given displacement, which is 45.599 tons. So the increments, we need to get the increments, so which is 59.28. Then if the LCF is negative, then it should be subtracted to the given displacement. However, the sign for the LCF given is positive, therefore we should add the first correction. Then we have there the second correction to be added always. So we have here the hydrostatic displacement, which is equivalent to 45,677.22 tons. Okay, so for the final displacement, we need to have a correction to the density, since our density is not 1.025, but if the density of the water is 1.025, then there's no need for us to calculate. So directly, if the value of the density for that area is, or location is 1.025, then automatically the final displacement would be the hydrostatic displacement. But in this example, we have 1.020, so we need to calculate. So 45,677 times 1.020 given displacement divided by 1.025. So that would be the final displacement, 45,454.40 tons. So if we are going to get the value of the weight of the cargo, this example does not involve initial displacement. Therefore, we should apply the light displacement and the consumable to the final displacement. So how will we be applying these values? So we need to subtract it in order for us to determine the weight of the cargo. So we have here 45,454, then minus 10,690, the light displacement of the ship. Then the answer minus 4,142. So we have the cargo weight, which is 30,622.4 tons. Or it could be that the initial displacement, like for example, if we have the initial displacement before the final displacement, then the value for these two could be subtracted and we could have the value of the weight cargo, which will be the same. Alright, so we are done. If this video will help you, please do not forget to subscribe on my channel because it will be a very big help. Do not also forget to please hit like and also hit the notification bell for you to be updated for our future videos which will be uploaded soon. And please share this one to your crewmates, to your students, and I hope that I could help you soon through my educational maritime needs. So that would be all. Thank you and